Okay, so good day to our grade 8 Mathematics Science High School students. So this is going to be our first lesson for the fourth quarter, for our final quarter on circles. Okay, we're going to try a very challenging problem from the get-go. So let's try to jump right ahead with this problem. Okay, 49. In the diagram below, ABCD is a square. The two circles touch each other and also touch two sides of the square. The centers of the square P and Q lie along a diagonal AC. Now, what is the length of the side of the square ABCD if the radius of each circle is 1? Okay, so for this problem, it's very important to find the distances, or the uh, to find the distances between the radius of the circles, especially the ones on the diagonal. Now, we already know that this is a radius, so that means this should be 1. This also a radius, that means this should also be 1. Okay, therefore AC is equal to 1 plus 1 plus these two side measurements here. Okay. Now, we know that this is a circle, so therefore it makes sense that this should also be 1 and this should also be 1, since that's the radius of a circle, the radii of a circle. This also 1 and this also 1. And we created a right angle here, and as well as here, and here, and here. So therefore, what type of shape have we formed at the ends of these diagonals? We form squares. Okay? And if we form squares here, and we know that the side measurement of these small squares, these two small squares, are 1. So therefore, the measurement of the diagonal for this square is just going to be 1 squared plus 1 squared, which is equal to c squared. And that should give us 2. 2 is equal to c squared. Take the square root of both sides. So therefore, the length of this distance from the distance here, so that's square root of 2. Okay, just to clarify, that's not 1 because the radius reaches until only here, but not here. There's going to be a gap. There's going to be a small gap here. And that gap is filled by the abundance from 1 as given by square root of 2. Okay, since we know that this is square root of 2, and that is square root of 2, so we can add here square root of 2 and square root of 2 to find the exact value of AC. So therefore, AC is equal to 2 plus 2 square root of 2. Okay, now let's go back to our big triangle. Again, we have triangle ABCD, and on the big triangle, AC is a diagonal as well, and this is a right angle. You can try to recall the pattern for the 45, 45, 90 using a shortcut. So if we have 45 degrees and 45 degrees as our side measurements as our angle measurements for the square, with opposite sides x, so therefore this could be x and then x. Okay, and our hypotenuse could be square root of 2 times x. Okay, so therefore if our hypotenuse is equal to x squared of 2, and we know that our diagonal is equal to 2 plus 2 square root of 2, so that's going to give us this formula. There you go. And since we want the value of x, the side measurement, okay, let's say for example that s is equal to x, so we can divide both sides by square root of 2. Okay, dividing both sides by square root of 2, so this cancels out. Okay, and therefore x is equal to 2 plus 2 square root of 2 all over square root of 2. Now we don't want a square root of 2 here, so therefore we can multiply both sides by square root of 2. So that should give us square root of 2 times 2 plus 2 square root of 2 all over 2. That's a mouthful. And this should give us 2 square root of 2. Okay, and square root of 2 times square root of 2 is just 2. Okay, there you go. And that should give us 4, right? So that's plus 4 here. So that's going to be 2 times 2, which is 4. Okay, so again, so that's 2 square root of 2. Okay, so that's square root of 2 times square root of 2, which is 2. And 2 times 2 is 4, all over 2. Now this cancels out. Okay, so this gives us square root of 2 plus 2. Or simply 2 plus square root of 2. Therefore, the measurement of the side, the measurement of x here, or the measurement of the side, is just 2 plus square root of 2 units. And therefore, we have solved the problem. The answer is letter B. And we use Pythagorean theorem, our knowledge about diagonals of squares, and also 45, 45, 90 in a special right triangle pattern in order to solve this problem. And that's it for solving circular problems applying geometry concepts such as the Pythagorean theorem and the special right triangles.